Hello, in this video we're going to verify double angle identities. The first two I'm going to work with is this one and this one. These are the most important two in the bunch. So I'm going to start with sine of 2a. Make sure you memorize this. To verify this, to show this is true, that is, what I'm going to do is I'm going to use the sum identity for cosine. So let me write that down. I mean the sum identity for sine. Okay, so what is the sum identity for sine? Well, we know that the sine of a plus b from a past section, we know that that is the sine of a cosine of b plus the other way around. Cosine of a sine of b. So if I want to verify this, all I got to do is put a's everywhere there's a b, because we only are doing a double angle, sine of 2a. So this tells us that sine of a plus a, which we know is sine of 2a, equals, right, sine of a cosine b plus, plugging in a cosine a, everything is an a now, sine of a, that's better. So that tells us that sine of 2a is equal to, well, just add these two coefficients, and because these are the same terms, that is 2 sine of a cosine of a. That verifies that identity. So now let's do cosine of 2a. To do the version that we starred, right, I'm going to use, to verify this, I'm going to use the sum identity for cosine now. We know from the last section that the cosine of a plus b is cosine a times cosine b minus sine a sine b. So again, plugging in all a's, you will have this identity. We'd have cosine, the same thing before as a plus a, which is 2a, is equal to cosine of a and times another cosine of a minus sine of a times another sine of a. So that tells us that cosine of 2a is equal to cosine squared of a minus sine squared of a. Now, personally, I just memorize those two because the other two versions of cosine are just coming from the fact that sine squared plus cosine squared is 1. So, for instance, if I verify cosine of 2a equals 1 minus sine squared, 1 minus 2 sine squared of a, I'm going to use the fact that sine squared plus cosine squared is 1. So let's go ahead and do that. Or that cosine squared equals 1 minus sine squared, which is just rewriting this equation. So let's go ahead and do that. Okay, so I'm going to start with the left-hand side, cosine of 2a. And we already verified on the left that this is equal to cosine squared of a minus sine squared of a. Now, I want to get this all in terms of sine. So I'm going to use this and substitute this in for cosine. So what do I get? This is our normal way of verifying, is start with one side and use other identities to get to the other side. So what do we get? We get that cosine is 1 minus sine squared of a. That's what this is. Minus a sine squared of a. That is equal to 1 minus sine squared of a minus another sine squared of a, which is really 1 minus 2 sine squared of a. That proves it. That is really easy to do. So I usually don't memorize that one. I just will do this every time. But it's up to you. Let's go ahead and do the last and final cosine. We're going to do that the other way. And we're going to do this the same way. Scroll down a little. We're going to use the same fact. We know that cosine squared plus sine squared is 1. So now I'm just solving for sine squared, and you get 1 minus cosine squared. So let's go ahead and do that. So what do we have? We have cosine of 2a is equal to, again, let's write down the definition we proved on the left, cosine squared of a, whoops, sorry about that, minus sine squared of a. That's the identity that we used over here. So what is that equal to? So now I'm going to replace sine. Well, this is a little trickier because we have a minus sign in front of there. So instead of sine, I'm going to plug in that with the minus sign. So I'm going to put in parentheses 1 minus cosine squared of a. And because of the parentheses, well, let's scroll down. We have to distribute that negative. Whoops. Erase that. Minus 1. That would be a plus cosine squared of a, which you see now you get 2 cosine. 1 plus 1 is 2. 2 cosine squared of a minus 1. We added coefficients. You can see that we get the third form. So there's actually, if you go back up here, there's actually 3 different forms for the same identity. I will use them interchangeably whenever needed. Finally, let's look at tangent of 2a. And to verify that, we're going to use the sum identity for tangent. So let's write that. So tangent of a plus b is equal to tan a plus tan b, 1 minus tan a tan b, and I'm going to do it the same way as I did the others. I'm going to replace everywhere there's a b, I'm going to put in an a. And so what do we have? We have tangent of a plus a, which is equal to tangent of 2a. And that is equal to, let's just write this here, tangent of a plus another tangent of a, all over 1 minus tan a, tan a. So putting everything in a's, the left side is tangent of 2a, and the right side, we add these coefficients, 1 plus 1, the same as we did before, 2 tan of a, all over, scroll down just a little bit, to get 1 minus tan squared of a. And let's see if that's right. That is that identity, which is the same final identity here. So that's verifying all the double angles identities. Hope that helps.